Hi class, Mrs. Lowe here. As promised, I'm going to continue to do some practice problems that were from your homework in Chapter 3. This is from page 210, the Chapter 3 review, and this is number 7. I'm going to go through B, D, and F. So on page 210, 7, B, D, and F. So I have them written down already. So we're asked to simplify these expressions, and you cannot leave any terms with negative exponents or zero exponents. So first thing we're going to do is we're going to multiply 3 times 2, which gives you 6. And now we're going to multiply the powers of k. Now when you multiply, you actually add their exponent. This k has an exponent of 1, and this one of a negative 2. So 1 plus negative 2 is negative 1, k to the negative 1, k to the negative 1. And then we're going to add the exponents of m. M to the 2 plus negative 2 is 0. So we have m to the 0. So we have 6k to the negative 1, m to the 0. So the 6 doesn't have a negative exponent, so it's going to stay right where it is. The k to the negative 1 does. In order to get rid of that, it's going to go to the denominator and it will lose the negative. M to the 0 is just 1. This is just 1, so nothing happens to that. It's just gone because that's equal to 1. So your final answer is 6 over k, which you could rewrite without the power of 1. 6 over k. 7D. In this case, we're dividing the terms, and when you divide, you subtract the exponents. So we keep the base, u and v, but we're going to subtract the exponents. It's top minus the bottom. So it's the top negative 2 minus the bottom, which is negative 3. And this becomes a plus 3. A double negative is a plus 3. So this is actually negative 2 plus 3. So this is u to the first. For v, it's top 3 minus the bottom. So 3 minus negative 2. Top minus the bottom. And this becomes a plus 2. So that's 3 plus 2, which is 5. So v to the 5. Neither of them have a negative exponent, so our final answer is u v to the 5th. U v to the 5th. And I'll just highlight that. And last one, 7F. There's multiple ways to do this, and I'm going to actually, depending on time, show you 2 different ways to do this. The first thing you could do is distribute the power of negative 2 to each one of those terms. And each one of those has a power, even though you don't see it. So the 2 gets the power of negative 2, the a and the b. And when you do a power to a power, you multiply. So I'm going to keep the bases, and I'm going to multiply that negative 2 to all 3 of those powers. So I have 2 to the negative 2, a to the negative 2, and b to the positive 2, because a negative times a negative is a positive. You are not allowed to have negative exponents to be simplified, so anything with a negative exponent has to move. The 2 to the negative 2 goes to the denominator, it becomes positive. The a to the negative 2 goes to the denominator, it becomes positive. The b squared is already positive, so it stays. And again, we want to simplify all the way, so we need to get rid of that 2 squared or simplify that to 4. So b squared over 4a squared. Final answer there. Now that is not the only way to do this problem, so I'm going to show you another way. The second way you could do this is you could get rid of this negative right off the bat by flipping the entire problem over, and then it loses its negative. So all I did was move this to the denominator, and the 2 lost its negative exponent, and it just becomes positive 2. Again, I need to distribute this power of 2 to all 3 terms, so it's 1 over 2 to the 2, a to the 2, and b to the negative 2, because a negative times a positive is a negative. The only term that has a negative is b, so it's going to move. It's in the bottom, so it's going to go to the top. It loses its negative, and then 2 squared is 4a squared. So b squared over 4a squared, which is the same answer we got before. Hopefully this helped.